Hi there again and welcome to the channel, Cambridge Advanced Level Mathematics channel here. In today's video, we are tackling question number 6 of paper 2, 2022. The question is up there on the board, but it's not written in full. I summarized as usual because of space on the board. Unfortunately, I'm just concentrating all the workings on this half of the board because my camera sometimes is not very clear when I extend it to the other board. So for lack of space, I had to squeeze everything down up here. But anyway, the question says a curve has the equation y is equal to 9e to the power 2x plus 16 divided by e to the power x minus 1. Show that the x coordinate of any stationary point satisfies the equation e to the power x multiplied by 3e to the power x minus 8 multiplied by brackets 3e to the power x plus 2 is equal to 0. Let's repeat the question to make sure we understand what we need to do here. This is the equation of the curve. At any stationary point on the curve, we need to prove that the x coordinate satisfies this equation. Now that since they are talking of a stationary point or a maximum or minimum point, we're not so sure what kind of a point it is, but it's a turning point. We need to ask ourselves, what do we know about stationary points? Well, we know that dy dx at a stationary point is equal to x. So why don't we find dy dx? All right, so I'm going to write this thing as y is equal to 9e to the power 2x plus 16 bracket again e to the power x minus 1 raised to the power minus 1. What have I done? I've just brought this here upstairs and the power becomes minus 1. Why do I do that? Well, I find it nice and easy to use the product rule because as it is, you may have to use the quotient rule. Not a problem, but I like the product rule. So that's why I write it like this so that it becomes a product. So differentiating this, we get dy dx is equal to, of course, we first of all differentiate this, which is 18 e to the power 2x. Let's put it in brackets. Then we multiply by this one here, minus 1 to the power minus 1. Then we come over here. Now we must differentiate this with respect to x. But our expression there remains as it is. So we are going to have a 9 e to the power 2x plus 16 there. And then differentiate that. We have the power there, minus 1. Then our e to the power x here, because the derivative of this, which is inside here, is just e to the power x. Then, of course, multiplied by e to the power x minus 1, now raised to the power minus 2. Okay, so now that we've done the differentiation, we can bring everybody down. That needs to be brought down. This is squared down here. This will be to the power 1 down here. So let's write it as 18 e to the power 2x divided by e to the power x minus 1. I've just brought down this guy. Then, of course, look at that. It's a minus sign. So it's now minus, and there's an e to the power x there. E to the power x, brackets, 9 e to the power 2x plus 16, all divided by that to the power 2, x minus 1 raised to the power 2. Okay, common denominator will be this one squared. So we can write this as, space is going to be a problem. Okay, I will just get rid of that stuff here, if you don't mind. I will make use of this. I am, of course, working on the technical issue of making sure we use the whole of the board here, because what we're doing is really not sustainable. So, but anyway, what I'll do now is I'll put everything under the common denominator, e to the power x minus 1 to the power 2. Okay, how many times does this one go there? It goes e to the power x minus 1 times. So we have 18 e to the power 2x multiplied by e to the power x minus 1. What about this one here? It goes, same story, it's just e to the power x brackets 9 e to the power 2x plus 16. Right. Now that we identified the fact that at a turning point or stationary point, dy dx must be 0. So now this is dy dx. Okay, let's remember, this is our dy dx. But now if it's to be 0, the only part of this fraction which can be 0 is the denominator. This can't be 0. We can only equate the top, the numerator, to 0, because once we try and make this one 0, then we're talking infinity. So let's deal with the top and say that it is equal to 0. So let's make the conclusion that at a stationary point, comma, dy dx is equal to 0, which implies, and this implies that now the top here, and we can remove the brackets, the top here is 18 e to the power x times e to the power 2x, of course, becomes e to the power 3x, minus that 18 there, 18 e to the power 2x. Then here we have got minus 9 e to the power, again 2x, e to the power 2x times e to the power x gives us e to the power 3x, minus 16 e to the power x. Right. It looks like everywhere we can get an e to the power x. So we can factor out our e to the power x. Of course, first of all, before we do that, this and that are similar. So we can write this is 18 minus 9. That gives us 9 e to the power 3x minus this one here, 18 e to the power 2x minus 16 e to the power x. Okay, this is where we are now. Okay, we equated the top to 0, then we removed the bracket. This is what we got, and that subtract each other to give us a 9, and then we have got this one here, and we've got that one there. Okay, so once we are here, what can we do? We need to factorize this thing. We need to factorize. First of all, let's take the e to the power x out. So we can say e to the power x goes here, e to the power x goes here and there. So we have e to the power x. Let's put a big bracket. Here we will have 9 e to the power 2x. Here we will have an 18 e to the power x, and here we will just have a 16. Square bracket. Now, how do we factorize this? Look at it as a quadratic equation. Just imagine that we have, supposing we make it, this was e to the power x was actually t. Then this one will be 9t squared minus 18t minus 16. So that's the way you have to look at it. if you are going to factorize it. So we'll have e to the power x, this one outside here, bracket, 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 bracket. What must we have here to give us a 9e to the power 2x? Surely we must have an e to the power x here and an e to the power x here. Right, sorry, a 3e to the power x, I beg your pardon. 3e to the power x. What are the factors of 16 that can give us an 18 here? Remember, if I put a 2 here, I'll get a 6e to the power x. Once I have a 2 here, I must have an 8 here. So 8 times 24 and a 6 will combine to give me an 18. So let me put a 2 here and an 8 here. Which one must be positive and which one must be negative? I need a minus 16. So it's a minus 8 and a minus 2. So now I have 24 e to the power x plus 6 minus 24 plus 6 gives me a minus 18. 8 minus 2 gives me a minus 16. A 3 and a 3 gives me my 9 there. So this, remember this again, is the condition that we concluded that if dy dx is to be 0, the top must be 0. So this must be 0. So there we are. So every x coordinate of the stationary point must satisfy this equation. The other part of the question, which I didn't put on the board, was actually saying, show that there is only one stationary point and find the x coordinate of that stationary point. Now here we are now with this equation here. There are two possibilities. If this is to be 0, then either we have 3e to the power x is equal to 8, or 3e to the power x is equal to minus 2. Those are the two possibilities. But one possibility is to be counted out, because there is no number that we can raise e to, number x that we can raise e to give us a negative number. So this one is out. The only possibility is 3e to the power x is equal to 8, from which we can conclude that e to the power x is equal to 8 over 3. So that's the value of that's the only possibility. This one being ruled out because of the fact that the 2 is negative there. This is the only possibility. So therefore, there is only one stationary point happening when e to the power x is equal to 8 over 3. Of course, they want us to find the actual value of x. So we have to take logs to base e. So ln of that will be x ln e, of course, which is 1, is equal to ln 8 over 3. So, of course, the logarithm of e to base e is just 1, so this is just an x. So therefore x is equal to ln 8 over 3. You can punch that in a calculator and find the answer to the required number of significant figures or whatever it is.